Good morning, sir. This is Chandana from CSE. Today I am going to explain about relational set operations from database management systems. These are the contents what I am going to explain in the relational set operation. First of all, I am going to explain about introduction to relational set operations. Next, types of relation set operation. In the types of relation set operations, and I am going to explain next union operation, intersection operation, difference operation, set operations, and SQL. And I'm going to explain about practical examples of set operations, performance considerations, and use cases for relational set operation. At last, I'll conclude all the subtopics with a conclusion. First of all, introduction to relational set operations. Relational set operations are fundamental operation in database management systems. They allow for the manipulation and retrieval of data from relational databases. Understanding these operations is essential for effective data querying and analysis. Next, types of relational set operations. There are primary relational set operation, which includes union, intersection, and difference. Each operation serves a specific purpose in combining or comparing data sets. These operations can be applied to tables with similar structures and relational databases. First of all, I'm going to explain about union operation. Here is the union operation. The union operation combines the results of two or more select queries. It returns all unique records from the combined data sets, eliminating duplicates. Unique records, which means it doesn't have any duplicates and doesn't repeat any record. The data sets involved must have the same number of columns and compatible data types. Next, intersection operation. Intersection operation retrieves records that are common to two or more data sets. It is useful for identifying shared values across different tables or queries. Like the union operation, the sets must be same number of columns and types. In this intersection operation and union operation, this is the common similarity. And next I'm going to explain about difference operation. Difference means we know as minus or difference between any two things. The difference operation, also known as minus, returns record from the one data set that are not present in the another. This operation helps in filtering out unwanted records from the specific data set. Both datasets must be compatible in terms of structure for the operation to work. This is the set operations and SQL. SQL means structured query language. We know as structured query language, which provides syntax for performing relational set operations. The keywords used include union, intersect, and except for these operations. Understanding SQL syntax is crucial for executing these operations effectively. These are the practical examples of set operations. An example of union operation could involve the combining customer list from two different stores. An interaction example might involve finding customers who made purchases at both locations. A difference operation could show the customers who only shopped at one store, excluding the other. These are the performance considerations. Performance can vary based on the size of the datasets involved in the set operations. Efficient indexing and database design can significantly speed up these operations. Understanding and underlying data and query optimization techniques is essential for its performance. This is the performance considerations in the relational set operations. Next, these are the use cases for relational set operations. Relational set operations are widely used in data analysis and reporting tasks. They help in data cleaning, integration, and deduplication process. Business and utilize these operations to drive insights and make data driven. Next, I'm going to explain another use case for relational set operations. Suppose you are working for a company that sells cloth online, selling online business, and your organization uses a database to manage data related to shipping, customer information, inventory, and website traffic. You have a key to this database that accesses all tables related to shipping, and you need to find out if you have enough inventory to ship out last last week's orders. Since the relation database organizes that their relation between shipping information and inventory, you can use your key access inventory numbers and shipping requests to compare data. During this request, you don't access any information about website traffic because your key only access the tables of the data that are related to shipping. This is the one of the best example for use cases for relational set operations. And next, I'm going to explain about how relational database works. Relational databases are built on relatively simple concepts that can become increasingly complex as the data contained within the grows. Database management system, which is also known as RDBMS. An RDBMS is a program that enables to create a update and perform administrative tasks with a relational database. The difference between a relational database and an RDBMS is the relational database organization and information based on the relational data model. It contrasts RDBMS is database software that allows users to maintain the database. This is the concept about the RDBMS. Processing requests and retrieving information. In RDBMS, user input SQL queries to retrieve the data needed to specific job functions. SQL, which stands for Structured Query Language, it standardizes a way to request information from the relational databases. At last, before to conclude my topic, I want to explain about relational database features. The database types are used to processing and managing transactions. They are often used in retail, banking, and entertainment industries where an excess amount is withdrawn from the one location or one account and deposited into other. The transactions like this have properties that can be represented by A acid properties, which stands for atomicity, consi- consistency, isolation, isolation, and durability. First of all, I'm going to brief about atomicity. All parts of the transaction are executed completely and successfully, or else the return transaction fails. Consistency. Data remains consistent throughout the relational database. Data integrity or the accuracy and completeness of the data at hand is enforced in relational database with the integrity constraints similar to the rule of enforcers. And next I'm going to explain about isolation. Each transaction is dependent of another transaction. Data from the one record does not spill to onto another. So it's very secure, which is known as isolation. Durability. Durability means even if the system fails, data from completed transactions are safely stored. By taking the relational approach to data queries, data and business analyst can perform specific functions to obtain the information they need to organize the query results by name, data, size, and location. This relational model also means that the logical data structure, such as tables and indexes, are completely separate from the physical storage. At last, I'll conclude my topic with this. Mastering relational set operation is crucial for effective database management system. Practicing these operations with real databases enhance understanding and skill. Always consider performance and optimization when working with large data sets. When we have to store large data sets, we need to use database management systems, which is very secure and very safe to manage, and it's more easy to access, and its data storage will be in secured manner. And thank you, sir. Thank you for giving this wonderful opportunity to explain about relational set operations.